Well, welcome back, everybody. Everyone's doing okay. Here, let me get a few more people coming in. All right. Okay. So I'll let them in as they come in. A couple of things. There's something going on with Canvas. I don't know yet. I got a thing out tech support, but I've graded some stuff, but it's not showing up. Hopefully by the end of the day or tomorrow, it should show up and figure out what's going on. So and then the other thing is I sent out a couple of files, which I'm going to go talk about today to help you out with respect to this particular end of this chapter and the beginning of the next chapter. And something else. Some people are for some reason not seeing some images in the homework or in one of the activities. If you're not seeing an image, shoot me an email, tell me which one it is, and I definitely will give you credit for it. Now, I've been told by tech support that the best browser that works well with Canvas is Chrome. So if you're not seeing certain things, I think I got one or two messages, you might switch over to Chrome and or at least update it. Okay, I'm still working with tech support to get more information in that aspect. It is that some people see the image, some do not. There's no rhyme or reason trying to decipher why that's the case. Okay. And then finally, with respect to Canvas again, Canvas doesn't quite understand. It's not AI, artificial intelligence. Okay. So if you type in an answer and you inadvertently give it a space, it will not understand it and count it as wrong. So whenever there is any answer, 100% it's correct, but Canvas marks it wrong, shoot me email, and I definitely will give you credit for it once they check it. Which reminds me, right now it's early in the semester, and it's not too much of a problem. I did send an email concerning this. Is that Canvas treats everything online as a quiz, and so but we break it down. We say we got homework, you got an exam, activities, and they each have their own name. But Canvas says quiz. So if you tell me quiz, it's not going to help me out because I need to know specifically: is it the homework, what number it is, and what number of questions? Okay, that way I can help you out ASAP. We don't have to figure out. Right now, it's pretty easy because most everybody's either the first activity, first chapter. It's not a problem. But as we progress, some of you are beginning to go ahead 2 or 3 chapters, which is fine. This is good. And so if you tell me quiz, I don't know which one it is. So be specific. Okay. All right. Any questions about that aspect? No. All right. Well, let me see. We were on chapter 2. The plan is this. We'll finish chapter 2. I'm going to jump into 3, probably get about halfway through it, and then finish up 3 on Tuesday. And then Wednesday, as you know, we moved the exam to Wednesday. I've also moved some of the assignments over. So for you. So we were on slide 18. And this is the one where we talked about rounding numbers. Now, let me back it up a little bit to make sure what we were talking about. We were talking about significant figures. This is important because we need to figure out how many sig figs we have in the numbers. Why do we need to do that? Because once we do some mathematical function to it, our answer, whether we add, subtract, multiply, divide, cannot be more accurate than the least accurate value that you use to do that mathematical function. Okay, so that's where sig figs is what we're talking about. That's where sig figs comes into play. However, when we determine sig figs, we have to separate 2 things. One, the mathematical function, that is. One, when we add and subtract, the only concern is decimal places. We don't care how many significant figures you have. in whatever number you add or subtract. What we care about is your answer should have no more decimal places than that number has the least number of decimal places. When we multiply and divide numbers, now we're concerned about sig figs. Now, don't mix the two. Okay, so look at the math function you got to do. Once you determine that, then you either deal with sig figs or you deal with decimal places. So we went over that. Okay, now, now it's because once you do a calculation, as you well know, you can end up with a number with 100 digits. Okay, and you don't want to present that because that's not accurate. That's not correct. You cannot give an answer that's more accurate than the least accurate value you use. So we have to truncate it. We have to cut it off at some point. And there, to cut it off, we have to round it. We have to round a number. And we round a number based on what neighbor is with respect to the immediate right of that number that we're going to truncate. Now, when we're rounding that number, either that number stays the same or goes up to the next value, and that's dependent on the neighbor to the immediate right. I repeat, the number stays the same or it goes up. It doesn't go down, okay? You don't round down. It either stays or goes up. And we use a simple rule is we look at the neighbor of that number and we determine if it's numbered less than 5, then that number that we're going to truncate stays what it is, whatever it is. So if you take that number 5.4, we're going to truncate it at the first digit, first significant figure. So we look at the neighbor's 4, it's less than 5, so 5 remains 5, and therefore our answer would be presented as simply as 5. If that is 5.5, same rules apply. We get a 1 sig fig. We need a 1 sig fig answer. And therefore, we will look at the neighbor. It's 5 or equal to 5 or greater. And that's the case. So that 5 then goes up to 6. So we will present our answer as 6. Now, when we do the rounding, numbers are going to be dropped off. Keep in mind, you don't want to change the magnitude of the number. We don't want you. So when you get ready to look at the number, look and see what magnitude you're in. Are you in the 100 place, 1,000 place? Because your answer should be in the same magnitude. Okay. And so we'll give some examples of this. A good thing to remember is this. Look at the decimal point. If any number in front of the decimal point needs to be, we don't drop. Okay, let me state it this way. Any number in front of the decimal point before the decimal point is not dropped, but is changed to 0. Any number after the decimal point is completely dropped. We don't care about it. Okay. So, but before the decimal point, we care about it. We don't want to drop those numbers. They're going to be converted to zeros. For example, down here at the bottom of the slide, the question says, round that 5,400 to 1 sig fig. Well, 1 sig fig is that first position. 1 significant figure is that first position. So we have to round it up at the 5 position. Okay, so we use the rounding rules. We'll go look at the neighbor. Neighbor's 4. Therefore, it's less than 5. So 5 remains 5. That 4 now is changed to 0. Okay, we didn't drop it. We just moved it to 0. So our answer is 5,000, 1 sig fig. Okay, so when you look at that problem first, you can see that you are in the 5,000 mark. So your answer should be in the 5,000 level, not in the 5 level. If you drop those zeros, you have changed the magnitude. Okay, what do you want, $5,000 or $5? Okay, big difference, right? Okay, so keep that in mind when we talk about the magnitude. Look at the magnitude that you're in, and then change the numbers before the decimal point to 0, and anything after the decimal point, you can drop them. All right, so here in this particular slide, they're asking you to round the numbers to the 3 sig fig digits. So starting from left to right, we find the 3 sig fig position. So 1, 2, and 3 position. So the number 3 is the 3 sig fig position. And so everything to the right is going to be truncated. So we got to, before we do that, we got to look at the neighbor, which is 7, and determine whether that 3 stays 3 or goes up. 7 is greater than equal to greater than 5, therefore 3 becomes 4. Okay. And so our number with 3 sig figs would be presented as 1.84. Okay. Now you say, well, it's more accurate. I got 1.8374. True, understand that. However, your measurement may only be accurate to 3 significant figures. And so you can't be more accurate than the least accurate measurement. This could have been the product of 2 digits that had you multiplied and got 2 numbers that had three sig figs. So your answer should only have 3 sig figs. Okay, second one. We got to do the same thing. We got to go through the 3 sig fig position. So again, starting from the left, going to right, we find the 3 sig fig position, and that puts us on the number 6. Okay, so here we go. We got a number and decimal point. So we know that all those numbers after the decimal point, we can completely drop. Okay, because we're not concerned about them. We're going 3 sig figs, they're going to drop. We look at the neighbor, which is 2, and that allows us to determine whether that 6 remains 6 or goes to 7. In this case, it remains 6. Therefore, that 2 gets converted to 0. All right. And so our answer with 3 sig figs would be 7,160. Okay. If you drop that 2, where you at? You're at 716. Did we not change the magnitude by dropping that 0? Yes, because we are in the 7,000 range. Okay. Another question would say, well, what happens if I just drop the 3 and the 2 and substitute it with zeros? Okay, let's do that. All right, so you go through a scenario and you end up with this number, 716 is 0. And then you said, well, I'm just going to replace the 3 and the 2 with zeros. What has occurred here by doing that? How many sig figs does that number have? 7,160.00. Doesn't it have 6 significant figures? Right? Remember the rules for sig figs? That's correct. That's 6 sig figs. So by not dropping the 3 and the 2 and substituting them for 0, you have in fact increased the number of sig figs. The problem said rounded to the 3 sig fig position. Okay, so not dropping them would be an error by substituting 0, so you got 0.00. Okay, so let's see the next one. Scenario here, we have a number less than 1. Okay, and so you know, hopefully by now, that those are leading zeros, so they are not significant. So that's not, you can't, they just hold the decimal place. They are not significant with respect to calculations. Yes, they are significant. They are of value because they hold the position, the magnitude of the number, but they're insignificant with respect to any mathematical calculations you do with them. Okay. And so we start with 1, we go across, count 3, because that's where the problem tells us to do, to truncate and or round this number off to 3 significant figures, which would be the 1 after the 3. We continue with the same process. Look at the neighbor. Neighbor is less than 5. Therefore, the 1 stays 1. Remember that. The 1 stays 1. Does not go to 0. We don't round down. So our answer presented as follows. 24,925 inches. Go to 3 sig figs. Again, from the far left, we count from left to right. The 9 is our 3 sig fig position. So we need to either round the 9 up or leave it at 9. We look at the neighbor. Neighbor's the 2. Therefore, the 9 remains the same. The 2 and the 5 get converted to 0. Okay, even though there's not a decimal point, it's understood that the decimal point is right after the 5. Also, the magnitude is you're in the 24,000 range. Okay, so your answer has to be in the 24,000 range magnitude. If you drop the 0, if you drop the 2 and the 5, you're at 249, correct? We have changed the magnitude. You don't want to change that. All right. And then I believe, oh, okay. I thought we had one more then. All right, so when it comes to adding and subtracting, I brought this in early, we are concerned about decimal places. When we multiply and divide, we're concerned about sig figs. So think decimal places when you add and subtract. So we take this number, 13.5478 feet, okay? And we're going to subtract 11.20 feet. Now, obviously, 11.20 has the less decimal places and therefore is the least accurate. So our answer cannot have as many decimal places as the one that is least accurate. We do the math completely. We don't truncate anything first. You never truncate or round anything up first. You use the full numbers and then take it to where all the numbers, whatever they may be. In this case, it would be 2.3478 feet. Okay. And given that our answer to be 2 decimal places, we have to find the second decimal place position. Obviously, it's the 4. Okay, and then we apply the rounding rules because everything to the right of the 4 is going to get dropped. And we take the rounding rules, look to the right, which is 7, 4 becomes 5. So our answer is 2.35 feet. And don't forget your units here. Now, we're subtracting feet from feet. So your units is feet, not feet square. When you multiply units, you will get feet square, but not when you're subtracting, all right? So we will be using a little bit of very basic algebra, and you need to go refresh your memory on that if needed. Okay, we round it out because of 2 decimal places. Let's say you mistakenly, let me demonstrate what we mean about sig figs don't apply with adding or subtracting, okay? Because if you look at the numbers that you start off with, okay? If you look with this, how many sig figs do we have in 13.5478? Do we not have six sig figs?
Yes.
Do, right? What about 11.20? How many sig figs there?
4.
4. We got 4 sig figs. Okay. And our final answer, what do we end up with? Sig figs.
3.
3 sig figs, exactly. Okay. And so you can see that when we do the math function, add and subtract, how many sig figs we have to begin with, playing no factor in our final answer. Okay. If we were multiplying or dividing those two numbers, now our answer should only have no more than 4 sig figs. Okay. So adding and subtracting, no sig figs here. Don't think sig figs, think only decimal places, and don't mix the two. Okay, don't bring the two. It happens occasionally. All right, now It's just a refresher as far as your decimal places, your ones, your hundreds, tens, so on and so forth, just to refresh your memory, to give you an idea about magnitude. Okay. Now, when we multiply and divide, we are concerned about sig figs. And so your answer should have no more sig figs than that number that has the least number of sig figs. For example, we have 3.546. How many sig figs, guys, do we have there? Anybody want to take a shot at that? 3.546. How many significant figures?
4.
4,
Oh, exactly. And 1.2?
2,
2. Exactly. And so we have 4 sig figs, 2 sig figs. We're multiplying and dividing here, or in this case, multiplying. Our answer should have no more than 2 sig figs. That's the one with the least number. So we do the math completely. We get 4.9644, okay? Given that our answer should be in the 2 sig fig position, we locate the 2 significant figure position, that is the 9. So the 9 either is going to get kicked up to 10 or left at 9, and depending on what the neighbor is 6. So the 9 gets kicked up to 10. Carry the 1, we end up with 5.0. Okay. Now don't forget about your units there. We got M times M gives you M squared. And if we were to multiply one more M, it would be M cubed. One more M after that, M to the 4th power, M to the 5th, okay? Don't forget your units there. So with respect to adding, multiplying and dividing, we will end up with the number of sig figs of that number that has the least number of sig figs, okay? Even this, if we were to divide this example, our answer should have no more 2 sig figs again. Only when we multiply and divide. All right. Now, scientific notation, I mentioned this before. You will need a calculator that has this function, and this function is simply a means to input very large numbers or extremely small numbers into a calculator, so you can do some mathematical calculation to it. Most calculators cannot handle big numbers like this, and so you know, if you had one with 50 zeros, most calculators will not handle 1 and 50 zeros afterwards. Okay, so you got to use scientific notation. And this is just the means to put in very large numbers or very small numbers. Okay, now how does that work? Let's take an example of this number, 93 million miles, which is approximately the distance from the Earth to the sun. Now, we start on the far right corner where the decimal place would normally be, which is obviously after the last 0 right there. Okay. We also make note as to the number of sig figs in that number. 93 million has 2 sig figs. So we have to put it in the scientific notation format with the correct number of sig figs. Now, starting from the far right, where the decimal point is, we move that decimal point to the left until such time we find the last integer and we stop right before the last integer. In this case, the last integer as we go from right to left is the 9, so we stop right before the 9. Okay, we have 2 sig figs here, it's 93, so we write that as 9.3 times 10 to the 7. To the 7th, it signifies how many decimal places you moved from right to left. You moved 7 decimal places. But a lot of people get confused at what it looks like it's something real foreign. Let me tell you what it is, okay? It's just a shorthand way of writing this. 9.3 times 10 2, 3, 4, 5, 6, and 7. Okay. Scientific notation is nothing more than taking that number 9.3 and multiplying it 10 times and 7 times by 10. That's all it is. Okay. And and we know that 10, there's a 1 superscript 10 to the 1. So when we multiply these increments 10 to the 1, 10 to the 1 is 10 to the 2. There's 7 tens that we add. We add the superscript. Okay, so it's 10 to the 7th. So that's all you're doing. Now, the format for scientific notation is there's an integer. Right after integer is the decimal point, and then followed by whatever digits are left. Okay. Now, one might be tempted to write that as 93 times 10 to the 6 is written here. That is scientific notation for that number. However, and it's not in the correct format. Okay. Always you have an integer followed by a decimal point, followed by whatever number comes after, whatever numbers come after that, which could be integers or zeros. The neat thing about scientific notation, when there is a question about writing it with the correct number of sig figs, if you put it into sig fig scientific notation format, there's no question you have it is written with the correct sig fig. Because even if I had a 0 here, 9.30, that would give me 3 sig figs. Okay. And then times 10 to the 7th power. So when in doubt, now show an example how when you can use that to put it into scientific notation. For example, think about this. Take the number 200, has one significant figure. What if you were asked, write the number 200 with 2 sig figs? Okay. Think about that. We'll come back to that. Write that number 200 with 2 significant figures. Okay. Now, the other direction, notice that number here is a number greater than 1. The decimal point went from right to left. Okay. And we ended up with a positive exponent, positive 7 here. With numbers that are less than 1, look at where the decimal point is, 0.000, etc. We're going to do the same process, find the decimal point and move it to the place it right after the first integer we find. Okay. And so we're going from left to right. It's a number less than 1. Guess what? The exponent is going to be a negative value. Okay. As we did with the positive number, this one determine how many sig figs you have because your answer should be with the correct number of sig figs. So we move that decimal point and moves over 10 places. Okay, so it's 1.7 times 10 to the negative 10. Okay, now this is nothing more. It looks complicated like the other example. The only difference here is you're taking 1.7 and you are dividing it by 10. 10 times, etc. Okay. If I take 1.7 and I divide it by 10, 10 times 10 times 10, 10 times, I get that number, 0.000000, so on, 17. So this is just, the negative tells me I'm dividing by 10. It's another way to write this. But this is a very small number, okay? Very small number. All right, so that's scientific notation. So you may get a questions like this. It says, convert the following to scientific notation. Systematically, for step number 1, determine how many sig figs you have first, because your answer in scientific notation should also have the same number of sig figs. All right, so we do that first. And number 1, we got 548.005. Okay, we have total of 6 sig figs. So we're going to have 6 sig figs at the end. Number 2, 68,100,000. 3 sig figs. Our answer is going to have 3 sig figs. Number 3 has 3 sig figs also. The 400 at the end there are significant, the 4 and the 2 zeros, okay? And then 2000 only has one sig fig. So we have to write that number in scientific notation with one sig fig. All right, so number one, there's a decimal point, locate the decimal point. We're going to go from right to left, which means this coefficient is going to, the exponent is going to be positive. And we're moving it 2 positions, okay? The second one, we're going to move the exponent from right to left 7 times. All right. Number 3, it's a number less than 1. We're going to move that decimal point from left to right. Guess what? 4 times. So we have a negative exponent. And then 2000, we're going to move it from right to left. We're going to have a positive exponent. Okay. And so our number should look like this. They'll have the correct number of sig figs, 5.480055 times 10 to the second power, because it's positive. 68,100,000 written scientific notation is 6.81 times 10 to the 7th. Don't forget your units. That number 4.00, we correct number of sig figs times 10 to the negative 4. Okay. And then finally, 2 times 10 to the 3rd. And so because 2000 only has one sig fig. But what if you were asked, for example, write 2000 with 2 sig figs? What would I do? But then I would convert it to scientific notation. Okay. 2.0, that 0 is significant. So I would convert it to scientific notation because I can't write 2000 with the correct, with 2 sig figs simply by itself. And if I were to put a decimal point in 2000, I'm creating more significant figures. If I needed to write 2000 with 3 sig figs, guess what? There's 3 sig figs. If I needed to write it with 5 sig figs, there it is. 5 sig figs. That's 2000 written with 5 significant figures. If I needed to write it with 100, I'd just keep adding the zeros, okay? The point being that any number that's a little bit ambiguous, you're not sure if it's correct with respect to sig figs, simply convert it to scientific notation. You can't go wrong with doing that, okay? The scientific notation always shows the correct sig figs. All right, so how do we do this with respect to our calculator? Well, there's 3 buttons out there, as far as I know. I got 3 images of it. There's a button that looks as I've highlighted with a blue box there, on the left calculators, you have the times 10 to the x power. Okay, and then your calculator may have 2 letters, EE. Okay. On the far right is the Windows 10 calculator, scientific calculator. It uses these button EXP. So all these 3 buttons put you into the scientific notation mode. Another button you should be aware of is the button that toggles you back and forth to a negative value. On the Windows calculator, it is this little button right here. It's a +/-. If you toggle that, that causes that number you inputted to go positive, or goes from positive to negative and vice versa. It also is used to make the exponent negative. So the other calculators, you might want to find out which one it is. Look, this one and this calculator is that button. And I can't find where it is. Oh, and this calculator is, I believe it's that button. If you're not sure, shoot me a picture, an image of your calculator. We can look at it. Or otherwise, look at your manual for that calculator. Okay. That's your toggle for your negative value. So what do we do as far as inputting a number? Well, simply we want to input this number, 2.39 times 10 to the 9. Well, the way we do that is you type in 2.39 like you normally would, any regular number. Then you hit the button that gives you scientific notation. And in this case, it's the E button for the far right calculator. And then you input the exponent. Okay, that's all. You don't have to put in the 10 to the third power. You just input the exponent. And it inputs that value for you. Okay, now don't type in your number and then hit the times table and then you hit this function button that's by itself is 10 to the x. That's not scientific notation. Okay, so it's one of those three buttons. To get you in scientific notation, that puts that number in there. And from there, then you do whatever calculation you need to do, multiply, divide, subtract, whatever you need to do. You're just inputting this big number into your calculator. That's all you're doing. All right. So is another shot of that picture of your plus and your minus. Again, if you have a question about it, let me know and we'll see if we can figure it out or look at your manual. Okay. Now, you will need a calculator to do calculations, so make sure you get one. So let's input this number here. I'm going to do share my calculator. Where am I? Okay. This is my Windows calculator. Okay. I have it in the it's Windows 10. I have it in scientific mode. And so all I got to do is I'm going to type in 2.84, 2.84, like I normally would. Then I hit the exponent. Now, if for some reason, if this was negative 2.84, then I would hit my negative to convert that to a negative before I go move it into a scientific notation. Okay. And so I know it's a positive 2.84, but then I go into the scientific notation. So using one of those three buttons, in this case, the exponent, I click that. Note, I get a letter E and then plus or minus. Now I input my exponent, which is 23. At this time, using the negative positive button, I can convert that back and forth to a negative exponent if necessary, but in this case, it's a positive. Now that number 2.84 times 10 to the 23rd has been inputted into the calculator. Now I do the math like I normally would. I'm going to divide that by 7.24 exponent 12. Okay. Now I can hit the equal, and there I got this big old number. Sometimes the calculator just shoots all this big old number at you. Okay. To put it back into scientific notation, there's a button that it could be labeled SCI, but there is a toggle button that would take this big number and convert it into scientific notation. Note what's happened here. It's made a humongous number. Okay. Let me copy this. I'm going to share the whiteboard. Okay, and that is my answer that I received from the calculator. Okay, now that is not in correct format. So I wouldn't copy and paste that number and put it in my answer because it would be incorrect for multiple reasons. One, too many digits. Okay. And second, it's not in scientific notation because that E plus 10, and that is in the notation for the calculator. And so I need to truncate it at 3 sig fig position. So then I would rewrite it as 3.92 times 10 to, I guess, 10. Okay. And that's what I would input. Okay. Where am I? Oh, there. Okay. Give me 1 second. Something just came up. I'll be back in about 30 seconds.
Does anybody have this calculator? No. Okay.
What were you saying? I could barely hear you.
Thanks. If anybody had this version of the calculator.
What is that? The 34?
30. The 30x.
Oh, I got a 34.
Okay. I'm just trying to figure out the problems he's trying to show us.
I do have the 30x.
Do you know which buttons he's talking about?
Yeah, I'm trying to figure it out and I don't know.
Yeah.
I also have the 30x and I have no idea what he's talking about.
Okay, so I'm not the only one. Because I did find, like, here, like if you go on second, there's the EE right there.
Yes. That's your,
But-
that is your button. I was gonna mention that. I'm back. When we go back to the calculator, now notice in these examples, the function is, the primary function is up front. But your function could be a secondary function. And just like you mentioned, Mary Lou, you have to hit the second button and then the button in the back that's highlighted in the base of, it says double E, right?
Yeah.
That activates the double E. In this example, the double E button right here, I've got in red in the middle calculator. That's the primary function, so you don't have to do the secondary.
Okay, because on this calculator, it's also a second function, but I have that one right there,
It's
the 10, and then the x as the exponent.
oh no, that's different. That's different. That you don't want to use that one. That's the one here that I said not to use. That one right there. It's 10 and then the exponent. Okay. You don't want to use that one because that's 10 to whatever power, 10 to the, so that's scientific notation. So your button will be a double E. The newer calculators have the button that are highlighted in blue here to the far left, where you see it together times 10 to the X. You all see that? Some of the newer ones have this one. The older ones have either double E or the EXP button. And like I stated up front, that's a primary button, but it could be a secondary function like Mary Lou's, where you have to touch the second button first to access it. Okay. And we're going to run through an example here real quick. In fact, I heard that someone else had the same model you have, Mary Lou?
Yeah, I think 2 of my other classmates.
Yeah.
Yeah, I
Okay.
do.
Okay.
I do
Did
as well.
did you see that second button and then that double E button?
Yeah.
Yes, I've just found it.
Okay. So you hit the second, then the double E. Okay. Now the other button you need to find is that plus minus toggle. So you can, when you have to put in negative values. Now you wouldn't put the negatives, subtract negative button. You will find a button that toggles you back and forth to negative, positive values. Okay. Notice here, these are not the same. Let me highlight them. In this case, this button toggles back and forth. Do not use the negative. Okay, I'm crossing that out. If you want to make something negative, that's the negative function. That's the subtract function.
Find the button, the button circled in red, but this one right here at the bottom
Yeah, that should be it.
Yeah, it just puts the negative right there.
Exactly. That's your toggle button. Some of them have a plus a negative, some have just a negative like your formula. Okay. And that toggles your negative, your value to positive, negative. Okay. We'll run through a specific example. And as we talk through it, run it through your calculators and see if you get the same answer we get or I get. Okay. Okay. So well, here, in fact, try it here. Okay. If you type in your case, you're going to type in first the EE button. Okay, you're going to, let me restate that. If your scientific notation button is primary, then you just type in the 2.84. Okay. If your scientific notation is a secondary number, you hit that first, then you type in the 2.84. Okay, so try that. Okay. Oh no, let me restate that. Sorry. Those of you with the what was it, 30x? Okay.
Yes.
Type in 2.84. Okay. Now hit the second double E key. Okay. Now you can type into 23. Okay. What does your screen show you?
Mine says 3.92265194 times 10 to the 10.
Or you went ahead and did the math? Oh, okay. Because I was just inputting the numerator. That's
Oh,
okay. That's
okay.
okay. That's okay. That's good. That's all right. You did that because you got 3.92, then a bunch of numbers at the end times 10 to the 10th, right?
Yes.
Yes. Well, you wouldn't report 3.92, blah, 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 whatever numbers they were, because the digits you divided only have 3 sig figs.
Hmm.
So your answer has to be in 3 sig figs. You follow? And see if I
Yes.
still have, let me see if I still have it in paste. This is the number you probably got? Something like that, 3.9226519337, et cetera, right? That's probably what your calculator said. But
Something
you would,
like that.
yeah, something like that. But you wouldn't report that big number because look at the math you did. You divided 2.84, which has 3 sig figs, by 7.24, which has 3 sig figs. So your answer, remember when you multiply and divide, you own your answer your answer has to be in the same number of sig figs is the least number that has the least number of sig figs. And in both cases, they both have 3. So your answer should have 3 sig figs.
How did you get the 10 over the power of 10?
Okay, here's that number I just pasted. Do you all see that big giant number? My calculator, my Windows calculator gave me the E. See the letter E? Plus 10. This part right here. That is the format of the calculator. That is not scientific calculation. You have to take that E, replace it with the X times, and take the plus 10 and put 10 times, the plus 10 is the exponent.
So I'm kind of confused because on the 30, it has the times 10, but it has it to the 70th power.
Oh, 70.
Yeah,
you do-
so how would I get the 10 exponent? Because I have
Oh,
the
no,
times,
no.
times 10.
You got to make sure you did the right math. Did you multiply or divide?
I divided. I got the big number. It's exactly the same, except I have times 10 to the 70th power, like towards the end.
Yeah, I can rarely see it.
Hold on, let me close it.
Yeah, I'll tell you what I can do here. I will.
I got this answer, so I didn't know if. Oh, sorry. I don't know if I can, like, it's like e to the 36, but that's
Yeah.
why I was,
That's not right.
I got the same answer too, but mine is e to the 34.
that's weird. That's why
Okay.
Yeah. Oh, I see what, I see
I
what
was
you,
getting the e to the 34 as well.
uh-huh.
What I ended up doing was I just put in the 2.84 times 10 to the 23rd in parentheses, divided by the other number in parentheses, and I finally got the correct final answer. So maybe give that a
Okay.
try.
Yeah, I'm looking at your number again. Look at, Ken, you got a 10 in there. I don't know why you got it. I see what you did here.
oh,
No,
did-
no. 2.8 times 10. So when you typed in 2.84, then you hit your function key, it automatically gave you times 10.
oh, so
printed-
the e is already the 10?
Yeah, it should already be there. You don't have to type in times 10.
Oh, okay, that makes sense.
Okay. Okay, now let's go stepwise. Calculator and type in 2.84. You clear your calculator, clear everything. Okay, type in, clear everything.
Okay,
Okay, now type in 2.84. Okay, down. Hit second double E.
second double e, okay,
Okay, now type in 23.
23,
What does your screen show you?
2.484.
Yeah, okay, perfect. Okay, now take that, divide that by,
Oh, so I should do it in steps, right?
yeah,
Okay.
then hit the divide, 7.24, and hit the second double E, and then 12. Now hit
Okay, I got-
equal.
I
Now,
got
what do you
it.
got? Okay, now you got it. What was happening, you guys were typing in times 10. You don't do that. Because the calculator automatically, once you do your scientific function, your scientific notation function, it automatically knows to do that. You don't have to type in times 10. So what you see is this number here. What you're looking at, let me come back to it.
I don't
Yeah,
have
right
the-
here. What you're looking at is like a number like 1.234, 4, 5, 6, 7, 8, and then you may have an E and then the 8 is what you were seeing, what you showed me. But don't hit times 10. Okay? Devin, did you see how they did that?
Yeah.
Okay, don't do times 10. So you type in 2.84 and then you have the same type of calculator? Or
I don't
different?
have the double E. All I have is x10 to the power
Yes.
of 10.
Yeah, oh, perfect. So hit 2.84 and then that button and then 23.
And then divide that by
And divide
7.24.
0.24, hit your
That
sign,
same button.
same
then
button and
12.
12, and then hit equal.
All right.
What do you got?
Give me 1 second. It messed up and put the whole equation in the power of the 10 slot.
Okay.
So I'm just plugging it in again real quick.
Okay, how about the rest of you guys? Did you have any challenges with the calculator?
I got it
Oh,
right.
Go ahead.
I got the same answer as you got. So
Everybody got the same? Okay, good. Everybody's good. Okay,
Yeah, I'm still getting times 10 to the 34.
look,
Two.
you're using, let me see your calculator here.
Mine?
Yeah, your button.
Oh, my button. Let's see if I can find it.
There
Oh,
it is,
break.
right there, right? Okay, now
Yeah.
let me move it down.
Is that a TI 84?
TI 34.
Oh.
All right, let me tell you what, clear your screen. Okay,
All right.
type 2.84 and then that button and then 3. Let me see what your screen looks like. Okay, now hit your divide button. Okay, 7.24, then the button and then 12. Okay, then hit equal. And
So it's supposed to look like that, and then I press equal. And I'm
Yeah,
still getting 10 to the
You're getting
34.
34. Why are you getting 34?
I don't know, but what I do is I put both those separate numbers
Yeah,
on the opposite side of that divide line in parentheses, and for some reason that works. So
okay,
parentheses
because,
line 2.84, that button to the 23rd, end parenthesis line divided by the 7.24,
okay,
the button 12, end parenthesis, and it comes out correct.
okay. Because if I see what it's doing, your calculator, if I look at the exponent 23 and 12, that is 34 when I'm dividing 2.8 divided by 7.24. I see what's happening there.
I have a
right.
question.
Yes, go ahead.
Can I use the calculator, the TI-84, or do I have to be the 34?
No, you should have a scientific notation
Okay.
calculator.
I'm
Yeah,
also
what,
doing the E34 at the end.
yeah, you might, okay, try parentheses. That's unusual. And your answer comes out right. I don't know. You might want to check your manual. That is kind of different.
Yeah,
It's-
parentheses, it works fine, but without it, I can't get it to work.
Yeah. Okay.
Let me
Well,
see.
at least try it without the parentheses, Norma, and then try it with the parentheses. Put a parentheses in the numerator and denominator, and see you come up with 3.92 times
I tried
10
both
to
ways. I tried with the parentheses and then I tried without, and it still comes with the same answer.
the 34. Huh? What does your button look like? Same button?
Same thing with the exponent, the 10 and the exponent.
Well, I tell you what, we're going to have to research that one.
Okay.
What is the calculator number? TI
TI-184.
184.
Oh,
Okay.
84. Mhm.
Sorry, you broke up. TI 184.
Yes.
8. Oh, just the regular 8.4.
Yours is regular 84.
Mine's
Okay.
3.4.
Yours 34. Okay.
Yeah.
All right. Well, I'll research it from my end, but at least everyone else, only 2 of you are having challenges so far. Okay. So the rest of you got it, right? Yeah. You might work through the worksheets. There's some more examples there to make sure you're getting the correct answer. Okay. All right. Let me continue here. All right. So scientific notation, which brings me to the final part. Okay. This is called percent. You all know what percent is. You're familiar with it. You get a test that's worth 100 points, right? You got one coming up, right? You get 80 points. What's your percentage? 80 over 100? 80%, correct? And so the whole is a total amount, the total weight, the total amount of a material, and the part represents the smaller amount. In this example, we got a gold ring that has a mass of 239.45 and has been analyzed to have gold 198.38 grams of pure gold. What is the percentage? Basically 198.38 divided by the whole, which is 239.45 times 100. Okay. Now, obviously, you get this big giant number, and don't forget your sig figs. Sig figs, by the way, all the way to the end of the semester, we use sig figs all the time. Okay, so we've been talking sig figs. It doesn't go away; it comes back. So sig figs, you can't be more accurate than the least accurate number. You can notice that the numbers we did the math with both have 5 sig figs. Therefore, our answer should have no more than 5 significant figures. Okay, and that consists of 82.848% pure gold. So the part overhaul, nothing complicated here. Just like an exam. How many points over total number of points. Okay, tons of worksheets. You may want to work those through, especially when it comes to scientific notation. That TI has got me perplexed. It's interesting that it does give you that answer, and that there's got to be something else for that calculator. You guys, you still have your manual? You might want to look that up. just to check it. Okay. All right.
In the
Um,
chat, I
this-
just put what I put in and it worked and made me
Yeah,
try it.
Yeah,
It's
I
up
see.
right now.
I see how Devin, you put parentheses on that, but you shouldn't have to. That's what is perplexing.
Yeah, that was
Sure.
the odd thing, but
Yeah,
it worked for me. It's a workaround.
it's a workaround to figure out for sure what is the
Th-
correct way. And this is for the one with the button with the 10x, 10 to the X button. Okay.
This may not help, but earlier I was getting some funky numbers and I realized that there was just, I'd done something weird. So I just reset my whole calculator and then it worked fine.
Okay. You might give that a shot. When all else fails, pull the plug and restart it. Okay. All right. So that's the end of chapter 2. What I want to do is we're going to get into chapter 3. But before I do that, I want to share a couple of things that I sent to you that we're going to be using, because now we're going to be doing conversions. Okay. Conversions from English units to either from English units to metric or vice versa. Okay. Now the metric for some reason is a challenge. Now, FYI, the US has been trying to convert to metric ever since I was a kid. That's 100 years ago. And it is slowly changing, but it's kind of weird when you think about it, that you can go to the grocery store and get a gallon of milk, but if you buy some soda drink, it's a 2-liter bottle. Okay. So it's kind of a combination so far, but we haven't switched over yet. But I sent this paper file to you to kind of help you break up with the prefixes. That can be a challenge sometimes for people. But I think a lot of it, again, I think you're familiar with a lot of the prefixes. For example, kilogram, the K. We're going to use the 3 measurements here: mass, volume, and length. Well, we start off 1 kilogram. In 1 kilogram, there's 1,000 grams. And if you go across the volume in 1 kiloliter, okay, kiloliter, capital L, volume, it's 1,000 liters. And if we go to length, 1 kilometer, it's 1,000 meters, okay? So it's 1,000 units greater. Now we get below. For example, for mass, the common unit we use is grams. So we got grams on the far left. Now, how many years in a decade? Isn't there 10 years, right? 10 years in a decade. That means that there are 10 deciliters in 1 gram. Decigram, excuse me. Again, that means that in 1 liter, there are 10 deciliters. 10 years in a decade. And in 1 meter, guess what? There are 10 decimeters. Okay. Now, how many years in a century? 100, right? Century for centi, C-E-N-T-I. So in 1 gram, there are 100 centigrams. Okay. I sent this through a student email. So you might want to check your email. Okay. And in 1 liter, there are 100 centiliters. And in 1 meter, there's 100 centimeters. Okay. And it continues. The milli, how many years in the millennium? 1,000. In 1 gram, there's 1,000 milligrams. Okay. In 1 liter, there are 1,000 milliliters. See the prefix, milli? And in 1 meter, guess what? There's 1,000 millimeters. Okay. So the prefix really helps you out as far as determining how many you have of that. The only one you may not be familiar with is this one called, it has a letter U with a little dip in front. That's called the micro. Okay. So in 1 gram, there are 1,000,000 micrograms. And in 1 liter, there are 1,000,000 microliters. Okay. And in 1 meter, there are 1,000,000 micrometers. Now, you may be familiar with micro MCG. If you take vitamins, look at the label, you'll see MCG. Those are micrograms. So you're taking an X number of micrograms. All of these that I put up here in this table are ratios. They are conversion factors. You can write them one or two ways. For example, you can write it with kilogram in the numerator, grams in the denominator, or vice versa. How you write them depends on the units that you need to finally end up with, depending on the question. For example, the question may be, how many micrograms are in 0.125 kilograms? So what we do is we write down what we're given, 0.125 kilograms, and we write down the units that we're looking for, micrograms, and we start using conversion factors in between here to get rid of our units, okay? And you can see how kilograms cancel, grams cancel, leaving us with micrograms, which is the units that we're looking for. And we set up these conversion factors. Now, it's a matter of you plugging in the numbers in your calculator to get you that number, okay? Now, I can't overemphasize using this particular technique because down the road, when we start doing calculations for chemical reactions, we're going to use factors like this to get us from point A to point B. Okay. Now, you can convert anything if you have conversion factors. Now, we give you 3 conversion factors on the shapes table. 1 inch is equal to 2.54 centimeters. That gets you from the English to the metric. Okay. 1 pound is equal to 454 grams. 1 quart is equal to 946 milliliters. Every one of these you can write one or two ways as written here. Okay. It is no different than any ratio like your salary, $50 per hour. I can write it with 50 in the numerator or 50 in the denominator, or 100 miles per hour. I can write them in both means here. Okay. So refresh your memory about algebra, the letters, how they cancel out. Okay, because this way we're going to utilize, yes, these letters, things like inch, we want to cancel inch out, or pounds or milligrams or anything, refresh your memory with respect to simple algebra, nothing complicated. I gave you this before, which gives you conversion factors within the English units. Okay, 4 quarts in the gallon, 2 pints in a quart, 2 cups in a pint. Exactly. So you got 3 more conversion factors here. Okay, each one can be written in any multiple ways with whichever you need, depending on the units that you need to be canceled. For example, I'm gonna give you a very extreme, crazy conversion factor. And I made it that way on purpose to demonstrate the craziness of what you can do if you have conversion factors. And I used this example way back when I was teaching at Carrington for dental hygiene students. So that's what the DH stands for, dental hygiene students. And I gave them this, I wanted to figure out how many DH students are equal to 4.5 bananas. You're like, what are you talking about? Dr. Fred's gone nuts. All right, well, maybe so. But I gave the conversion factors. All right. 1 DH is equal to 6 grapes. 3.5 grapes is equal to an orange. An orange is equal to 6 toothbrushes. And 3 toothbrushes is equal to 1 banana. Totally obscure craziness, but that's okay, because I'm going to utilize this to determine how many DH students equal 4.5 bananas. You're going to look at this, you see this here, but you're going to see it down the road when I say, okay, calculate how many grams of carbon dioxide are created from 55 grams of sodium bicarb. Okay, totally different, totally apples and oranges in extreme, but not to worry. We're going to have conversion factors to get you from point A to point B. So the first thing I do is I write down what I have. I've been given 4.5 bananas. Okay. My ultimate goal is unit wise to get down here at the bottom someplace to equal how many DH students. That is my ultimate goal. That's my roadmap. That's where I gotta go. So I write down what I'm given, write down where I gotta go. Now I use my conversion factors that I know and or have been given to start breaking down or getting rid of the units. Because I know one of the conversion factors, I got bananas. I need something that gets rid of bananas. Well, I got one. I got 3 toothbrush per banana. So I write it in a manner so bananas cancel when I do the math. Do not the bananas cancel when I do the math like this? Yes. Do they not? So at this point, I'm at the toothbrush. I've already converted my bananas to toothbrushes because I have that factor. But I'm not where I need to be because I need to be down all the way down to DH students. So I got to find something to get rid of toothbrush and put me into another unit. And sure enough, I got 6 toothbrushes per 1 orange. And again, as I proceed, I am going along, canceling the units that I'm done with so I can keep track of where I have been and where I need to go. Okay. Now, if I stop the calculation right now, I'm in oranges, but that is not what the question asked for because I got to keep in mind, I got to get to DH students. So now I got to find something to get rid of oranges. Well, I look at my conversion factor. Sure enough, I got a conversion factor that relates oranges that I can get rid of and puts me into grapes. And I write it such that oranges get canceled out. If I write it like this, okay? Still, I got one more unit. I'm at grapes. I got to get to DH students. And then finally, with respect to the units, okay? And I'm following the units. Now, some people may be tempted to take these numbers like 3.5 grapes to 1 orange, and then they want to invert it and change the value. Don't change the value. Leave the value as is. Okay, 3.5 grapes to 1 orange, and just write it, put it in numerator or the denominator as needed. Okay, don't change the values that you were given. So at this point, I am unit-wise right where I want to be. So this is an example of how to demonstrate your work, okay? Many chemical reaction calculations you're going to be doing will have at least 3 conversion factors, all right? And if you set it up properly because you understand what's going on, and for some reason you inadvertently hit the wrong button in your calculator and get a wrong number, you will not be taking points away because you wrote down the wrong answer, but you have shown how you set it up. Question like this could be worth 5 points. The answer may be worth 1. The rest may be worth 4 points. Okay, so if you give me a wrong answer, I only take 1 point away if you set it up properly. Okay. At the same time, if it's worth 5 points and you just give me the answer, well, you didn't show me the work. I can only give you 1 point. In other words, I don't think you should be penalized for giving me a wrong answer if you set it up properly and you understand how to get to the answer. Okay. And this is what I meant earlier about I 99% sure, 99.9% sure. If you set it up like this, you won't have a problem. And the other percentage I can't account for, and that's you pushing the calculator numbers. Okay. All right. So finally, going through all that, doing the math, I end up with 1.3 dental hygiene students is equal to 4.5 bananas. So see how obscure this example is? That's okay. It demonstrates that you can convert from anything to anything given conversion factors. All right. Down the road, like I said, we'll be using this technique. Now, I know you'll be tempted. I know in high school you were taught to use ratios. And I can almost guarantee you that if you do this here, that when you get to the 3rd ratio setup, you might be off a little bit. But if you set it up with my units here all set up and you follow the units, you should not have a problem. Okay. Okay, clear as mud, right? I'm looking at your faces like, what is this man talking about? All right. Was gonna jump into chapter 3, but it doesn't look like we're gonna do that. So we're gonna run through chapter 3 on Tuesday. So let me drop this.